Okay, here's the video for the last page of the review. And I know that you guys are probably happy. So, Pharrell had a recent tour, and the number of attendees were constantly growing. Pharrell's audience is represented by this function right here. 1,000 times 1.5 to the x, where x represents the x show. This is going to be important. It says, for example, the x equals 0 denotes his first show. So we're going to come back to this, but it says create a table of values. Alright, so enough of the happy song, I guess. And how do we do that on our calculator? We are going to enter, let's turn it on, go to y equals, clear out whatever functions. We're going to put this function in there, 1,000 times 1.5 to the x power. That's our exponential function. They want a table. I'm going to go right second graph to get the table. Make sure we can see that. Can you guys see that with the light? Okay. So, at 0 shows, 1,000, first show, or at when x is 0, that is his first show, because it says when x is 0 denotes his first show. He has 1,000 people. His second show, when x is 1, is 1,500 people. 2250 and 3375. So this is his first show. This would be his second show, third show, fourth show. Okay? This is important right here. We have to read that problem because it says when x is 0, it denotes his first show. Important. So creating the table of values, we did that for number 1. Now, how many people will attend in his 10th show? So here's our function. F of x. So we want f of, or we can just say y, 1,000 times 1.5 to the what? It's not going to be 10th, it's going to be 9. So we're going to put 1.5 to the 9th power. Okay? Let me rewrite that here. Y equals 1,000 times 1.5 to the 9th power. Okay? It's 9th because his first show is when x is 0. So that means his second show is here when x is 1. Third show, so it means his 10th show is when x is 9. We're going to put that in the calculator, or we already have it here. We could scroll right down and look at our table. Whoops, the glare is a little bad. There we go. So when x is 9, the number of people, 38,000. This is going to equal 38,443 people. Okay, if we didn't want to put it in the calculator like that, we can say 1,000 times 1.5 to the 9th power, and we're going to get the same thing. Okay, so explain how you found your answer. So I could say I plugged 9 in for x because that represents his 10th show. Okay? Alright, that's how we do that one. Kyle's commenting on Facebook. Kyle's comments are represented by this function. Create a table. We're going to enter this function into our calculator. So we're going to clear out. We're going to say 36 times 2 to the x power. Go directly to our table. We'll scroll. It wants to start at 0, so at 0 it's at 36, 72, 144, 288, 576, and at 5 it's at 1152. Okay, so we created the table of values. We did that. How many comments will Kyle have by the 7th week? So y equals 36 times 2. Now we got to be careful here. Here's the number of weeks. It tells us the number of weeks is 0. This is the first week. the second week. So by the 7th week, we just put 7 in right here. Not like the other one. We got to make sure. Two different problems, kind of. Got to read that problem carefully. So when we get that, once again, if we already have it in the table, we could scroll right down to 7 and get 4,608. 4,608 post. I guess Facebook post. Okay? Explain how you found your answer. So you could say that I plugged 7 in for X because that represents the 7th week. Okay. Last problem, 21A and B. So Jasmine has 85 pairs of shoes and she's selling 6% of her shoes each month. So she starts with 85%. That's the initial value. We're going to write that function. She's selling. So is this exponential growth or decay? It's going to be decay. She's getting rid of shoes, which is y equals a times 1 minus r to the t or x. Okay? So what's the function? It's going to be y equals 85 times 1 minus. What's my r? Well, 6% turns into 0.06 as a fraction. So we say 0.06 to the t. We could clean that up a little bit and say y equals 85 times, right on your calculator, you can do 1 minus 0.06, and we're going to get 0.94. So 85 times 0.94 to the t power, or the x power is fine. Okay? Explain why 85 to the x to the 6th power is not a reasonable model. Well, 85 mx is not exponential, and the problem models exponential decay. Whoops, sorry. Okay, we just got to write something about that. This is not exponential. Even though it has an exponential, exponential is when the variable's in the exponent. This is not exponential. Okay? Last problem. So Alfie has 187 Hot Wheel cars. Initial value. His collection is increasing. So it's going to be exponential growth. It's increasing by a percent. Not a stagnant amount, but a percent. So A times 1 plus R to the t power. Y equals 187 times 1 plus, well, what's my R? 14%, which changes into 0.14. 0.14 to the t power. We're going to clean that up and say it's y equals 187 times 1.14 to the t power. Explain why this is not a reasonable model. Same as number 2 up there. Okay? You're going to write that sentence out though. Alright. Good luck on the test, and hopefully you guys are going to be happy.